So in this video, we're going to be talking about polynomials, what they are, and then performing some operations with them. So first, I kind of want to start off by specifying what exactly is a polynomial and some different terms that you should know for polynomials. So first of all, what I have written down would be considered a polynomial of degree n. The way that we can figure out that it's degree n is we look at the exponents of the different terms on the x, and we're going to choose the highest one. So see, we have n, and then we have this n minus 1, and we're counting down all the way to 1, and then at the end here, this is actually an x to the 0 term, so we're literally counting down from n all the way to 0. So this polynomial is in what we call standard form because we have decreasing exponents or powers. So we look for the highest one, which is n, and this is going to be the degree of our polynomial. And then we have these different coefficients here. So this a sub n minus 1, a sub 1, and a naught. These are all coefficients. Of our different x terms, right? And then we have this a naught gets a special name. This is called our constant term. Notice this, it's the only one when we have written that we don't have attached to an x. That's really because it's the x to the 0 term, and anything to the 0 is equal to 1. So really, if we have a naught times x to the 0, that's really a naught times 1, which is just a naught, which is why we just write a naught. And then we have this term over here, which is up at the front of our polynomial. It also has it's the one that specifies the degree because it has the highest exponent, and we call this the leading term. So that would be the whole a n x to the n. And then sometimes we'll want to specify the leading coefficient, which is just going to be the coefficient of the leading term, so that's the number an, okay? All right, so now we're going to talk about doing some operations with different polynomials. So let's say I wanted to add two polynomials. So maybe I have x squared minus 9x plus 1 as one of my polynomials, and I wanted to add this to the polynomial 4x cubed minus 5x squared plus 2. Now, we're going to combine like terms here. And what I mean by like terms is terms that have the same exponent. So for instance, I have this x squared term and this minus 5x squared, and so these are actually like terms and I can combine them, right? Same thing with the constant terms 1 and 2. And then we'll notice that we only have one x term, the minus 9x right here, and we only have one x cubed term, which is this 4x cubed. So when I go to combine my like terms, I'll have my x squared minus 9x plus 1. I'm just adding to this 4x cubed minus 5x squared plus 2. I'm just writing this all out. Really, I'm just dropping the parentheses. And then I'm going to combine. X squared minus 5x squared gives me a negative 4x squared. And then I have this minus 9x. And then I have 1 plus 2 gives me a plus 3. And then I have this plus 4x cubed. So notice all that I did was I combined our like terms here. And then, I didn't specify to do this necessarily in the problem statement, but if we wanted to write this in standard form, we're going to rearrange the terms in descending degree. So I'm going to start with the highest degree term, and I'm going to go down to the lowest degree term. And when I'm talking about the degree of the term, I'm talking about the exponent of the x. So my highest degree term would be this 4x cubed, and then I have minus 4x squared, and then I have minus 9x, and then a plus 3. And notice that the sign in front of the term stuck with it. Like when I moved the 4x squared, I moved it with the minus 4x squared. When I moved the 9x, I moved it as a minus 9x. Okay, so we may also want to add polynomials that maybe we need to distribute something first. So maybe I want to add 2x squared minus 9x plus 1 to, actually, we'll do minus 3 times this 4x cubed minus 5x squared plus 2. So all I've done is I've added this 2 and this 3 here, which are being multiplied to the polynomials before I go ahead and combine them. And so we're just going to distribute these, just as you probably distributed when you were solving linear equations. So I'll distribute the 2, and I'll distribute this minus 3. And I'll write out what I get, and then I'll combine my like terms. So for this first one, I get 2x squared minus 18x plus 2, and then I get minus 12x cubed plus 15x squared minus 6. And now we're going to combine like terms. The 2x squared combines with the 15x squared to make a 17x squared. The plus 2 and the minus 6 combine to make a minus 4. And then we have these two terms that don't have any other like terms. So I have minus 18x minus 12x cubed. And now I'm just going to sort them by highest degree to lowest degree with my terms. So I have a minus 12x cubed plus 17x squared minus 18x, and then a minus 4. Okay. All right, now we're gonna do one more where we're distributing, but this time we're gonna distribute a term with an x on it. So let's say I had 2x, x plus 5 minus 3x, 4 minus x squared. Let's say I wanted to write this in standard form maybe. So I need to expand everything, combine all my like terms, and write it from highest degree to lowest degree. Well, the first thing I'm going to do is distribute this 2x and this minus 3x just like I distributed the 2 and 3 before. So I'm multiplying these in. But now we need to think about what happens when we multiply 2x times x. Well, if I have x times x, that's just an x squared. So then this is going to give me a 2x squared. If I multiply something like 3x times an x squared, this x times x squared is really just x cubed. So then it will be a 3x cubed. So notice that it's just changing the power in my x, because I just want to show how many factors of x are in that term. So for this first one, we have 2x times x gives me a 2x squared. 2x times 5 gives me a 10, and then I just have one factor of x. 3x times 4 gives me 12x, so I have minus 12x. 3x times x squared gives me 3x cubed. I have a minus times a minus, a negative times a negative, so I have a plus 12x cubed. Whoops, 3x cubed. And then I go ahead and combine my like terms. So I only have one x squared term, so I just have 2x squared. The 10x and minus 12x combine to make a minus 2x, and then I have plus 3x cubed. If I want to write this in standard form, I'm going to sort the terms in descending degree. Okay. Now I just want to specify something with this one. Suppose we wanted to list off what our leading coefficient was. Maybe we wanted to list off our constant term. Maybe we wanted to list off what our degree was. Well, when we look for the leading coefficient, we're looking for the leading term, which is the term with the highest degree on our x. If we put it into standard form, it's just going to be the term up front. So we already put this into standard form. So our leading term is 3x cubed, so our leading coefficient would be 3. Our constant term for this one, we're basically looking for that number that's added on to the end that isn't attached to an x. Really, it's attached to an x to the 0, but that's just 1. And this one, we don't have an appearance of that. That doesn't mean that we don't have a constant term. It just means that it's not written. And that's because we could put a plus 0 here, and that doesn't change this polynomial any. If I'm adding 0 to it, it doesn't, change it at all. And so our constant term here would just be 0. If I had a number at the end, then it would be that number. And then our degree is just going to be the exponent of our leading term, right? Or the highest exponent that we see on the x's, and the highest one that we see is 3. Okay, so now we're going to talk about multiplying some polynomials together. So suppose I wanted to multiply x plus 4 and x squared minus x. So up in this previous example, we had taken this 2x, for instance, and we distributed that into times x and times 5. Well, we're going to do the same thing, but with this x plus 4. We're going to multiply that by an x squared and by this minus x. So I'm taking this whole term, x plus 4, and I'm multiplying it to x squared, and then I'm multiplying it to the minus x. So I'm still distributing. So I've got x plus 4 times x squared, and then I have minus x plus 4 times x. Well, now I can distribute even more, right? I can distribute this x squared, and I can distribute this x. This might look a little weird because I'm distributing from the back, but it doesn't matter if I have x squared times x plus 4, or if I have x plus 4 times x squared. These two are the same thing. They're exactly equal. And so if you distribute this x squared from the front, that's the same as distributing the x squared from the back. So on our next line, we would have x and x squared give us an x cubed. 4 times x squared gives us 4x squared. And then we have minus x times x, which gives me an x squared. And then minus x times 4, which gives us a 4x. Now I'm going to combine like terms. We've got x cubed. It doesn't have any other x cubed terms. Our x squared terms combine to make plus 3x squared. And then we have this minus 4x. So that's what we get when we multiply those two polynomials together. We'll do one more example like this. So suppose I have 5 minus x squared times x cubed plus 3, we'll do x squared. Actually, let me add plus 1. Okay. Now here, we're going to play the same game. I'm going to take this polynomial and I'm going to distribute it into the other one. So I'm going to distribute times x cubed times 3x squared and times this 1. Notice we just distribute it to each term. So if I had 4 terms, I would do 4 multiplications. And I'm going to write out what I get. I have x cubed times 5 minus x squared plus 3x squared times 5 minus x squared plus 1 times 5 minus x squared. I'm not going to write the 1. You can if you want to. And then we're going to go through another round of distributing. And this is just distributing a 1. So then we get 5x cubed minus x cubed times x squared is going to give me an x to the 5th. And then I have 15x squared minus 3x to the 4th plus 5 minus x squared. And now we go ahead and combine like terms. So I've got only one x cubed term, only one x to the 5th term. I have 2 of these x squared terms, so I'm going to combine them to make a plus 14x squared. And then I have this minus 3x to the 4th and plus 5. If I want to write this in standard form, I just need to sort the terms in descending degree. So my highest degree term is this minus x to the 5th. And then I'm just going to go down 4, 3, 2, 1. So my x to the 4th term, my x cubed term, my x squared term, my x term, which I don't have, so I'm going to leave it off, and then I have this plus 5 at the end. And this would be our polynomial written in standard form. If we wanted to list the degree, that would be 5. The leading coefficient would be this negative 1, and then the constant would be this plus 5 off at the end.